Hey everyone, today I want to show you how to do some auto scaling with Omni. And if you have a cluster that you say, I want to add more nodes dynamically, we have a solution for that. And I'm going to do the whole demo using Oxide today. Oxide has some pretty cool hardware that ships on-prem. They gave me some resources to do some testing with. And so I'm recording a video to show you how we could scale up in maybe a dynamic way with something that's not bare metal, because bare metal doesn't auto scale, but VMs do. I have a quick GitHub repo that walks through the steps to show you how this works, assuming you have an Omni account and access to Oxide. But if you don't have those things, don't worry, I'll show you how to do these. This isn't specific to Oxide either. This works in any virtualized environment. You could do similar steps for VMware, Proxmox, OpenStack, whatever, or even a cloud provider. You say, I just need to add machines from this environment and I need them to auto scale in this cluster. Omni can handle that auto scaling for you, so let's show you how. First step here is we need to install the tools. I already have these installed, obviously, so I don't need them. You also need to set up authentication if you require that for something like Oxide. I'm going to be using image caching in my VMs because I just want to reduce some of the bandwidth required to download and bootstrap a cluster. So these images will be automatically pulled and available on the disk even before Kubernetes is up and running. So I don't need to wait for Talos to download these from the registry. This also helps with reducing some of your, if you have quotas to different registries, or if you just have large images that you want to be built in. So I'm going to go ahead and do that. I'm going to download all these container images into the virtualized disk that we're going to push into Oxide so that it's already downloaded one time and not a bunch of times. Let's walk through those steps real quick. There's an images default command in Talos control. I'm just saving that to a text file. If I look at that text file, this is what it gives me. It puts the defaults that we know we're going to need. You could add whatever images you want to bake in. All that is needed is your client here needs to be able to pull those images. So if I had Argo or Flux or something else that I want to just bake into all of my disks, maybe it takes a long time to pull. Maybe I don't have a lot of resources for bandwidth, whatever. You can put them in this images, and we have another video on that. Just go look up that video. Now I'm going to just cat that file and pipe it directly to Talos control image create cache. And that's just going to create this cache folder of all of those files. Every artifact layer is going to be part of this file system. Again, this isn't something new. If you want to see how to install air-gapped environments, go watch our other video. We'll have it linked. I'm going to make a out folder because that's where we're going to save our disk image once it's ready. And I need these Omni args. The Omni args are how machines know to join my Omni instance. If I go back in Omni on the home page, I have this copy kernel parameters, and I can copy that right there. It's on my clipboard, and I'm going to name that Omni args as an environment variable, which configures my Omni endpoints and also my join token for these machines. And if you're running Omni on-prem, this works the same way. That is all the same sort of flow. You could be using the SaaS, you can run it on-prem, whatever. We just need a join config so the machine knows how to join Omni. And here, this Docker command is going to mount in the cache folder, secure boot, and the outs and dev. We're going to run our imager container here. And we're going to say we want a metal image using the image cache. Here's my extra kernel args. And then we're also going to set up a disabled dashboard because we don't need that in Oxide, as well as the TTY for the console. So we get console logs back into Omni. And we're going to set our root disk image size to 4 gigs. So let's just paste that command in and get that running. This does automatically compress the image with ZST. So we're going to uncompress that. Right, here's the next command. We just want to uncompress it. We'll save it in that same folder. And now I have a raw image that I can send to Oxide to use for my boot volume. Here's the Oxide disk import command. We have a project already set up. We have the path where we're pulling it from. I'm going to change a couple things on this command because I forgot to update them. We're using Talos 194 instead of 191. And these are all just kind of some descriptions and things that say this is how we're using it. So we're going to upload that image to the Oxide rack, and that's going to become an image for us. If we look over here in Oxide, I have these disks, and now it's importing for bulk writes. So automatically it's happening for me already. I know that this is going to be a disk that's available that I can mount into new VMs. I can clone that volume and use it. That's just how normal VM disk cloning works. That's all done. So we can, like I said, list it out, and we can see our config here. This also has an ID here as a UUID that I need to use because I'm going to tell Oxide, create a VM and use this disk ID for the root volume. And again, that has Talos installed, that has my disk cache in here. So if I go into my Oxide folder here and I have a instance templates, and that's what I'm going to be using. And I need to change my image ID to that new image ID for the new image that I just created. The other things in this template is just, I'm going to name them Talos with a number, some generic information. I create a new disk from that image. So each machine gets its own boot disk. And I just say I want 2 CPUs and 4 gigs of RAM for each one with default networking. Now let's go prep Omni. In Omni, we need to have what's called a machine class. If you go into Omni on the left here, you'll see your machine classes. Right now, I don't have any. You can manually create these. You can go into them and you can search for different things that create a machine class. So I could say I want all of my, say, AMD 64 that have 60 gigs or 6 gigs of storage. That's my class. And I could name this whatever I want. And that now would be matchable based on these labels. And you can set these labels at boot time with configuration to the kernel or different boot media. However you're getting those machines into Omni, you can automatically set those. What I'm going to do for my class, I'm going to say I want platform is metal. And let's say I want memory is 4 gigs here because I am setting all these machines up to have 4 gigs of memory. Again, you can do this however you want. That's how I'm going to divvy them up because that's what mine are going to have. I'm going to call this class Oxide and a create machine class. So now I have a class that will match any machine that has a platform of metal, which is the ISO we started with, and it's going to have a match for 4 gigs of RAM. You could also do this in the command line with something like this machine class here. And this is just match labels on whatever it is you want to match. So I could send this directly to the Omni API. Now, the next thing we need to do is we need to create a cluster. Even though we have no machines in Oxide created yet, we're going to use a cluster template. Cluster templates are just YAML files that declare some things about the cluster. So in this case, we would have something like the name of the cluster here, what version of Kubernetes we want, what version of Talos we want, what patches we want, if we want to apply patches. And in this case, I want to enable the local image cache so that it is used from disk. It's not going to have to download all those images. It's going to be ready and just pull from localhost. And I'm going to say I want 3 control plane nodes from that machine class. So that machine class is going to say, I have a metal machine class. Give me 3 nodes. I don't care what they are. I don't care which ones they are. They just need to become the control plane. And then the rest of them down here are going to be unlimited size. Everything else in that machine class, whatever else joins Omni with a platform of metal and 4 gigs of RAM, add it as a worker to this cluster. That's what this cluster template is going to do. And we can apply that cluster template directly to Omni with a CLI. We'll look at Omni control as a cluster subcommand template, and we're going to sync it. We're actually just syncing this to the API. I'm actually going to update my config here because I just forgot I named that Oxide. So let's swap those out. So now it's using the right machine class. I also added another little patch here because we want to disable kexec on Oxide. We had a few things that happened with it that occasionally a node got hung. So we're just going to disable it altogether. And now let's sync that. Sync that back into Omni. And we should have, there we go. Now we have our workers, our control plane, the 2 patches we want, and the cluster itself. Going into Omni under clusters, I can see here that I have the Oxide cluster now. I click on it. I have nothing. I have no machines. Nothing has actually happened yet. It's not ready. It's waiting for machines to match. So let's make some machines. In this case, I have a little command here that I'll show you this script real fast. This is a single command with basically a random variable each time. So it's going to run this Oxide instance creates project Omni and using that template with environment variable substitute so that my name of my machines gets randomized. And I'm just going to run that as many times as I want. So in this case, I'm using xargs, which is going to run it 5 times, and I'll run it more than 10 times. Let's do maybe a 25 node cluster. So I can say sequence 25 xargs. Again, all we're doing is calling this script 25 times. And with a different iteration, again, no machines here inside of Oxide or in Omni. Let's go into Oxide. I got nothing right now. Let's go ahead and run that. And if we go over to the Oxide instances and we can refresh, I already have a bunch of them running. We got 6, there's 10. We're batching it in 5 nodes. All of these machines are just spinning up. They're booting off that initial image. I see some of them are already running. So they will show up here inside of Omni. Once they get booted, they will connect and I'll see them start coming in. These are the VMs that are coming in. I have 4 gigs of RAM. I have a platform metal, which means my machine classes, my Oxide machine class has machines now, and my cluster, my Oxide cluster is already provisioning. I have 3 nodes that are booting for the control plane. It picked whatever nodes connected first, and then the rest of the machines as they come in are booting and deploying themselves with Talos. They're getting all those patches we just set out. They're deploying Kubernetes. They're becoming a cluster. I actually see here in my Oxide capacity that I did run out of some capacity here. I don't have enough IP addresses to create all of these machines. So I was making those calls and they were failing because I didn't have capacity for that network. Even though the machines themselves don't have public IPs, they are consuming some public IPs on the NAT for port mapping. So let's see how many machines we actually got. Looks like we got about 15 nodes created. I don't have another page here. So we got 15 Talos nodes up and running. We can connect on any of them. So I can connect and view the serial console and I can see what's happening on the system itself. I can see that it was waiting for CRI, Kubelet's up and running, it found a host. So back here inside of Omni, my control plane's already up and I'm waiting for 2 more machines to become ready. So 15 and 11 are almost there. View the serial console, machine is running. I probably just needed to wait. Yeah, they're all running now. A couple things to point out here inside of Omni, we do let you know that this cluster is being managed by templates. So someone ran the API commands to sync a template into the cluster, into Omni. That's helpful to know. It doesn't mean you can't change things, but it does mean that they're going to get out of sync if you ever apply that cluster template again. So if I go ahead and say I want to upgrade my Kubernetes version, it doesn't sync back to my template on my file system. I can download that template and then use it. But right now I did a one-way sync into Omni and that's all that got applied. So these machines are up and running. What happens if I want to change one of them or I want to add more capacity to the cluster? I think I'm out of resources. So let's go ahead and scale this cluster down. We're going to go into Omni, say scale the cluster, and this little checkbox here that says use all instances, I'm just going to change that. I'm going to say I only want to use 10 of them. And again, we have warnings here because this is using a template. I'm overriding that template here. So we're going to update that. Dismiss, and now some of those machines are being destroyed because we said we'd only wanted 10. We didn't want all 15 for whatever reason. We're going to take them out. It's not going to go in any specific order. This is just 10 of those or 5 of those machines are going to be ejected out of the cluster. But I can still scale the cluster back up. Let's say I want to add some more machines into the cluster. Those machines are showing up here as resources available, right? These are still machines that are connected into my Omni instance. If I want to connect them back into my cluster, I would create a new machine set, which has, instead of using machine classes, I'm going to use a manual machine set. And I'm going to say, add this to worker, or W1 is my worker machine set number 1. I can't add it to the control plane or to worker 0 because again, those are using machine classes. So in this case, I can manually bring them in. I could say, okay, just add those back into the cluster. We're going to update them. And I get this new worker set down here, which is going to have those same machines just in a manually provisioned fashion. So anything that's coming in automatically isn't going to have that. If I go in and delete a bunch of these machines from Oxide, it'll scale down in the cluster, up to 10, right? So it's like, it's only gonna go up to 10, but it's not gonna go at like a minimum because it doesn't, Omni's not controlling where those machines are. Let's find a machine here. So like Talos 14. Let's go find 14 and let's just turn it off. Now that the machine stopped, let's go check it out in Omni. It is disconnected now. It doesn't know anything about it, but the node still exists. The node inside of Omni is still a thing, so it's not replacing it yet. It's not going to do any sort of replacement. Is that 14? Until I go into my machines and I find Talos 14 and I would remove it here. Now the machine is gone from Omni. Because again, bare metal, these situations, Omni doesn't know if you just rebooted a node, if it's coming back, what's going on. It's going to assume that if the machine exists in your machines, it should be available inside of a cluster, at least at some point. Going back in here, we see we went back to this scaling up portion where it does want 10 machines, but we only have 9. Only 9 are available. It's not gonna consume those from the workers down here because I statically provision those into a different group. And again, you can have multiple machine classes that are provisioned separately if they have GPUs or different resources or from a different provider, whatever it may be, those can stay static, not have to like contend for each other. The last thing I could do here is say I want to remove the machines from that manual machine sets and update that. And then I'll see as these machines get destroyed down here at the bottom, one of them will eventually go back into the pool and show up back here in this machine set as the final 10th machine that we want. There it goes. It's already booting and configuring it. It just deleted itself and, oh, you're part of the machine class. Please come in and fill the rest of the quota that I need. I want 10 machines. You are now my 10th machine. There we go. And that just goes right back into that pool to keep me at that state of how many machines I have. And then of course, if we destroy the whole cluster, everything goes away from here. It's just going to reformat all of those systems. It's going to wipe them from configuration, put them back in the pool of machines that are available to use. What I want to do actually is let's go ahead and just wipe all of those instances. I have a command for it. Here's my cleanup. I can delete the cluster and then here we go. Let's find all of the instances in my list and delete them. And this is going to stop the machine inside of Oxide and then delete the machine itself and delete the disk for me. So one of the things that I sometimes like to do because it's fun is to just see how fast we can scale up a cluster. And in this case, I'm starting again with 0 Oxide instances and I deleted all of those Oxide instances from Omni. So the other machines that were existing here, there's no more Oxide, there's no more Oxide cluster. And so I can sync that template into Omni. And I can do something like start a timer here and try to run as many Oxide. Oh, I'm blocking that timer, aren't I? There we go. There we go. And we can try to run those. Let's go back to 15 nodes because that's what we had before and see just how long it takes us to create this cluster with machines. And so in less than 40 seconds here, we can see that the machines are created inside of Oxide. I go into Oxide and refresh. I will see them all ready, almost all of them starting, one less starting, all of them running now. And I didn't even get a chance to show you the machine tab because all of them are already booting up in the cluster. We are 1 minute in and we almost have a working Kubernetes cluster. And again, this is provisioning all of the bits for Kubernetes. This is not only installing the operating system to make sure it's configured and ready to run, this is also going to be creating the control plane certificates, the etcd database. This is a highly available cluster with 3 nodes so that one of them can go down. I can rotate out those certs. This isn't like a toy. This is a production quality ready to go Kubernetes cluster. And in less than 3 minutes, I have a 15 node cluster, 3 control plane nodes and the rest of the machines up and running. And that's all there is to it. That's how you would create a Kubernetes cluster that can auto scale based on dynamic resources. Again, if you're doing it with bare metal, you're going to be scaling those a little slower. But in a dynamic environment, if say you are running on-prem and you need to burst into a virtualized environment, such as a cloud provider or a private cloud instance providing VMs, you can do that. And you can just add those to any cluster as needed with scaling up and scaling back down. I didn't have to write a whole bunch of Terraform or cluster API specs or anything like that. I have one template that defined my cluster, the machine classes that define how I want to batch machines together, and what machine sets I want them in. And then I can just add capacity, and I add that capacity from anywhere. It can join the same cluster. All of that capacity is just available for my workloads. It's transparent where they're running, how it's coming in there. It doesn't matter. A lot of times we get constrained into, you can only run VMware clusters in VMware, and you can only run bare metal on bare metal. Omni doesn't care how you got compute into Omni. As long as it can run Talos, it can be part of a cluster. Thanks everyone for watching, and thank you Oxide for giving me resources to play with and see how this would work in a dynamic environment, and we will talk to you all again soon.